Hi there, this is Max Bright at Lower Umpqua Library, here with the next video for our virtual science program. In today's video, we're going to look at thermal conductivity. That's how well energy, thermal energy, which we also call heat, transfers from one object to another. It turns out that different materials can have different thermal conductivities. That means the time it takes for one object to transfer energy versus the time it takes for another object to transfer energy can be different. The first thing we should know as we discuss thermodynamics, how we describe things that are hot or transferring thermal energy, is the 0th law of thermodynamics. A law is a thing we know because there have been no observations to prove it wrong. So this law is thermal equilibrium. As long as objects are in the same space long enough, they will reach the same temperature as the space around them. What that means is if I have objects on the table or all of these books here in the library, if they've been in this room long enough, everything will be exactly the same temperature. So I've got two objects here, and we're going to leave them out for long enough to reach thermal equilibrium. One is a plastic lid. The other one is a metal lid. So they're both lids, but they are different types of materials. Often we describe plastics as insulators and metals as conductors. So let's see how well these different materials can transfer energy. So what I'm going to do is put an ice cube on each one of these lids. And because of the 0th law of thermodynamics, thermal equilibrium, we know even those ice cubes, if we leave them here long enough, will reach the same temperature as the room around them. So that means they will melt, turn to water, and warm up if we leave them out long enough. But the time it takes the ice to melt might be different because of our two different materials. So let's put an ice cube in both lids, and we'll see how long it takes for ice to melt. Now, I'm not going to make you watch all of this at once, so I will break this into pieces. I'll show you clips as we go, so enjoy watching ice melt. All right, on our marks, get set, go. So let's check in on our ice. I can see in the metal lid, there's already a little bit of water underneath the ice cube. But in the plastic lid, there's almost no water. There's still just an ice cube. Let's let it go a little bit longer. Let's take another look at the ice cubes. Wow, in the plastic lid, that ice cube is still pretty big. And in the metal lid, there's still a lot of water, a lot more than in the plastic lid. Let's see how much longer it takes for one of those ice cubes to fully melt. Let's see how our ice cubes are doing now. They've been out in the room for quite a while. I'm still seeing very little water and almost the entire ice cube in the plastic lid. And in the metal lid, there's a lot of water, and the ice cube looks like it's about half melted. This might still take a little while, but it seems pretty clear to me that metal is conducting energy at a faster rate. All right, well, we're about 20 minutes into the experiment, and it's pretty clear which one is one. The ice cube in the metal lid has melted much faster than the ice cube in the plastic lid. This is showing us that conductors, metals, transfer thermal energy at a faster rate, so less time, than it takes a plastic insulating object. It turns out that not only are conductors good for transferring thermal energy, but they're often also very good at transferring electrical energy. This is why most wires are made out of metals instead of plastics. So that was pretty cool, or pretty warm, depending on what kind of material you are. If you'd like to see more of these science videos, be sure to check us out at www.luld.org and call us at 541-271-3500. And we'll see you at the library soon. Bye!